section 3.3. Huh. Okay. Section. Oh, I see it. It changed everything. So it's, no, I think you like this one. So let's do section 3.3. Slope of a line. Okay. Okay, so let's take a line in the plane and let's do this relative to some coordinate system. So I'll have some coordinate system, and let me assume that this is not a vertical line. And so meaning that this line is not parallel to the y-axis. And so let's take some point on the curve. Let's go 1 unit in the positive x direction. The number of units I have to go in the y direction, I'll call that m, and this will be called the slope of the line. So that number of units that I have to go in the vertical direction in order to get to another point on the line will be called the slope of the line. If I have to go up to get to a point on the line, I'll make the sign of the slope be positive. If I have to go down to get to a point on the line, I'll change the sign of the slope and make it be negative. So again, let me assume that I have some line relative to some coordinate system. And assume that this is not a vertical line. Then I can think of the slope as follows. I will always denote the slope of a line by the letter M. It's just the rise over the run. So rise divided by run. It is the vertical change over the horizontal change. It is the change in y over the change in x. It is the change in y, delta y, over the change in x, delta x. Okay. You should know all of these notations. I'll be using them interchangeably. it is, and I guess I'll draw it down here, y2 minus y1 over x2 minus x1. It is see, this is the point x1, y1, and this is the point x2, oops, y2. Then it's just this distance here, y2 minus y1 over this distance, x2 minus x1. And that is the formula for the slope. Note, maybe I can actually bring it up here. Let's see if I have enough room. Yeah, I can just leave it there. Okay, so note, the slope of a vertical line is undefined. When I was giving the definition here of slope, I always assumed that this was not a vertical line. Okay, so I'm assuming here it's not a vertical line. If it is a vertical line, well, I just haven't defined it. Either you say the slope is undefined, or sometimes people say that the slope is infinite. Note, however, the slope of a horizontal line is defined, and so it's a very nice, well-defined value. And it's equal to the value 0. So you go 1 in the x direction, but you don't have to go up or down any in the y direction to get to the horizontal line because you're already on the line. Note, warning, never use the term no slope, because I don't know what you mean by no slope. So don't use that terminology. Either say that the slope is 0 for a horizontal line, or say that the slope is undefined for a vertical line. Okay, let me give you some additional terminology. Parallel lines. So two lines in the plane, let's say L1, L2. So two lines in the plane are said to be parallel, and it's denoted by these two like parallel lines in between if they never intersect in the plane. Now let's draw this relative to some coordinate system. And suppose that neither L1 nor L2 are vertical lines. So that means that L1 has a slope, call it M1. L2 has a slope, call it M2. Well, we say that two lines are parallel if and only if their slopes are the same. And of course, this means if M1 is equal to M2 means, well, if M1 doesn't exist, then M2 does not exist also. Next, perpendicular lines. So suppose I have two lines, L1, L2. And again, suppose that this is relative to some coordinate system. And again, suppose that neither L1 nor L2 are vertical lines. So that means that L1 has a slope, say M1, and L2 has a slope, say of M2. Then L1 will be perpendicular to line L2, denoted by this symbol here. Oh, I didn't tell you what perpendicular is. Two lines are perpendicular if they intersect, and at that point of intersection, they intersect at a right angle. So if this point of intersection is a right angle, we say that, yeah, whatever. We say that these intersect, that these two lines are perpendicular. So L1 is perpendicular to L2 if and only if the product of their slopes is -1. Or we can just say that two lines are perpendicular if and only if one slope is equal to the negative reciprocal of the other slope. So note that in this sort of notation, if I have 0 times infinity, I get -1. Or if I take the reciprocal as 0, I get negative infinity. And if I take the reciprocal of infinity, I get 0. So in that notation, then it's if and only if. So let's do some problems. Let's say on page 121. And so in exercises 1 through 16, find the slope of the line passing through the given pair of points. Well, and so I have here the point 2, 3, and the point 2, 4. Okay. Oh, maybe I'll do it this way. I'll write it the second one first. So I have here -2, 4, and the point 2, 3. So let's call this x1, y1. Let's call this x2, y2. And so I want to find the slope, which is just y2 minus y1 over x2 minus x1. And so I have here y2 minus y1, 4 minus 3, over x2 minus x1, negative 2 minus 2. Okay, and so 4 minus 3 is 1. Negative 2 minus 2 is a negative 4. So my slope is negative 1/4. Let me do, let's say, problem number 7. 4, 1, and negative 5, 1. And so I'll call this x2, y2, and I'll call this, oops, let's do this in red. And I'll call this one x1. Oops, it's still not red. And I'll call this x1, y1. Okay, and so the slope, y2 minus y1 over x2 minus x1. And so y2, 1 minus y1, 1 over x2, negative 5 minus x1, 4. 0 over negative 9. Well, 0 divided by negative 9 is 0. So my slope is 0. It turns out that if I have a slope of 0, this is actually a horizontal line. Horizontal lines have slopes of 0. Any line having a slope of 0 will be a horizontal line. Let me do problem number 11. Three, 0. And the other point is 3, negative 3. So let's call this x1, y1, x2, y2. So the slope, rise over run y2, negative 3, minus y1, 0, over x2, 3, minus x1, 3. So I get a negative 3 over 0, but you can never divide by 0. Therefore, the slope is undefined. If the slope is undefined, this is a vertical line. Let me do, let's say, problem number 18. So, in exercises 17 through 32, find the slope of the line. So y equals negative 3x plus 1. So let's find the slope of this line. So I'll show you two different techniques for finding the slope of a line. So first, let me just pick points on the line. And so let's do x, y. Actually, we just need 2 points, so I'll do 0 and 1. Okay, and let's see, when x is 0, or maybe I'll do 1. I'll do a 1 then a 0. How's this? 1, 0. When x is 1, I get negative 3 plus 1 is negative 2. When x is 0, I get 0 plus 1 is equal to 1. Okay, and so let's say that this is x1, y1, and say that this point is x2, y2. And so the slope, y2 minus y1 over x2 minus x1. And so I have negative 2 minus 0, minus 1. So negative 2 minus 1 over 1 minus 0 is negative 3 over 1. So therefore the slope is negative 3. Okay, so I could just pick 2 points. Shoot. I could pick 2 points and graph the line. Hopefully people could still see the writing in the background. Can you see the writing in the background? Or do I have to? No. Okay, so I've got to, yeah, okay, so let's do this. Now you should be able to see it. In a few seconds should be coming up. Yeah. Okay, good. Okay, so let me show you a different way of doing this. So a different way is I'll use the following fact, that if I can write an equation of a line in the following form, y equal mx plus b, then this number in front of x will be the slope of your line, and this number here, not that it really matters, is the y coordinate of your y-intercept. So in this case, this says that if I have y equals negative 3x plus 1, then that says that the slope is negative 3. And we're done. And so we could have just right off the bat said, oh look, there was a negative 3 here, therefore the slope is negative 3. Okay, let's do another problem. Let's do problem number 22. Negative 3x minus y equals 2. So let me subtract 3x from both sides. So negative y equals negative 3x plus 2. Let me divide both sides of my equation by negative 1. And so I get y equals 3x minus 2. Therefore, the slope is 3. And we are done. Let me do problem number 30. So now, for these problems, to find the slope, it's just a algebraic sort of technique. You just solve the equation for y. And we've done that before. So I have 2y minus 3x plus 5 is 0. Let's solve for y. So let's add 3x to both sides of my equation. So 2y plus 5 equals 3x. Let me subtract 5 from both sides of my equation. So I have 2y is equal to 3x minus 5. Let me divide both sides of my equation by 2. And so I get y equals 3 halves x minus 5 halves. Therefore, the slope of this line is 3 halves. So let me do, let's say, problem number 34. And so this says to consider the lines A, B, C, D, E in the figure. For each line, determine which of the following is true. And so 1, slope is positive. 2, slope is negative. 3, slope is 0. 4, slope is undefined, is not defined. Okay, so let me draw this figure. Oh, maybe let's do some different colors. So A, B, C, D, E. That's it. A, B, C, D, E. Yeah. Okay. So slope is positive. So first, I guess, I want the slope positive. Oops. And so the only one that has a slope that's positive is B. 2. Slope is negative. Well, the only slopes that are negative are D and E. Okay. Next, slope is 0, so that would be a horizontal line. Well, the only horizontal line is A, and the slope is undefined. So the only vertical line is C. Okay. Let me do problem number 36. In exercises 35 through 42, without drawing the graph of the line, determine whether the line is rising or falling from left to right. And so, to determine, so I have here 2x minus 3y equals 7. To determine if a line is rising as we read the, or falling as we read the graph from left to right, I just want to determine the slope. So notice that if I read this graph from left to right, then my y values are decreasing, and so it's falling if the slope is negative. Whereas if I read the graph going from left to right, I notice that the y values are increasing, they're rising, and so and the slope is positive. Whenever you look at a graph, always read the graph going from left to right, and that will tell you how we've given the names appropriately. So let's solve here for y to figure out the slope. So by the added property of equality, let's subtract 2x from both sides of my equation. So negative 3y equals negative 2x plus 7. Let me divide both sides of my equation by negative 3. And so y is equal to positive 2/3 x minus 7/3. Therefore, the slope is equal to 2/3, which is greater than 0. Therefore, we are rising as we read this from left to right. Let me do, let's say, problem number 52. Y equals 2x minus 7. Or maybe y equals 2x minus 7. Y equals 2x plus 1. Let's call this L1 and this line L2. Okay, so in exercises, let's see, this is in exercises 51 through 78, determine whether the pair of lines is parallel, perpendicular, or neither. Okay, so let's look at line L1. Well, it's already in the form y equal mx plus b, and so the slope of the first line is 2, and its y-intercept is negative 7. The slope for the second line is also 2, and its y-intercept is 1. Since the slopes are the same, then these two lines are parallel. They could be coincident, but they're not the same lines because they have different y-intercepts. So since L1 is M1 equals M2, and since line the y-intercepts B1 is not equal to B2, then these two lines are parallel. So they are parallel lines. Okay. Let me do problem number, let's say 50, no, how about 62? Let's do problem 62. 3y minus 4x equals 3. Call that L1. L2, 3y equals 3 minus 4x. And so, let's look at L1. So I have 3y minus 4x is 3. Let me solve for y. So let me add 4x to both sides of my equation. So I get 3y is equal to 4x plus 3. Divide both sides of my equation by 3. So I get y equals 4/3 x plus 1. So therefore the slope for this first line is 4/3. Let's look at the second line. Three y equals 3 minus 4x. Divide both sides of my equation by 3. And so y is equal to negative 4/3 x plus 1. So therefore the slope of the second line is equal to a negative 4/3. Well, these two lines are not parallel. So not parallel. And the product, and well, one line, the slope of the second line is not equal to the negative reciprocal of the slope of the other line. So therefore they're not perpendicular. Therefore, they're neither parallel nor are they perpendicular. Let me do problem number 74. So let's say L1, y equals 2x plus 3 halves, y equals negative 1/2 x minus 1/2. Well, for L1, the slope is 2. For L2, the slope is negative 1/2. Since the slope, negative 1/2, is the negative reciprocal of the first line slope, 2, then these two lines are parallel, are perpendicular. So L1 is perpendicular to line L2. So we have perpendicular lines. Any questions about that? So, 12:46. Okay, so I guess that ends section 3.3, and on Monday we will start section 3.4, unless there's any questions. Okay, so that's it for today.